Hello, folks. So slightly different to the published title. Hopefully it's still interesting. If it's not, bye. But let's go with it. Let's let people exit the room. Cool. So I'm Mike Bassal. I'm the Chief Security Architect for Red Hat. I'm here to talk about what does it look like if you're moving to the public cloud and looking specifically at the sort of hybrid future. Just a brief agenda. What do we mean by private, public, hybrid, multi-cloud? Then talk about what's a sensitive application, because I worry about sensitive applications, sensitive data, sensitive algorithms, and how you deploy them, where they should be deployed, etc. Then talk about what a problem statement, a specific thing to worry about. Then we've got some controls we can use and a quick summary. And hopefully we can get out a bit earlier and everyone can have a beer, which is good, right? Okay, so just a few descriptions to start with. So this is the first one. This is your private, your on-prem cloud. You've got some workloads. They're the sort of little the sort of piece of bread shaped things on top of hosts, which is the blue stuff. If you're doing it in public, CSP is hosting your workloads for you. If you're doing hybrid, well, you've got some that you host and some that the CSP hosts, and that's all cool. Or you could be multi-cloud, where you're using multiple CSPs. Or maybe multiple instances of a single CSP. Well, why would you do this? Well, one is obvious for failover type stuff. You know, when that big AWS outage happened, if you're able to move over to another cloud, either from AWS themselves or from Google or somebody else or Rackspace, whoever it may be, then you've got more options, right? It's got to be a good thing. And then you've got your kind of maxi combo cloud, where you host some workloads and multiple CSPs host workloads, and of course, your maxi combo cloud comes with a free fries or a kid's meal, but restrictions do apply. So the point is here, we've got a number of ways of moving things around. Let's look at sensitive applications next, because you're going to want to think about where you put your applications, where they sit, who hosts them, how they're controlled. And so here are some I came up with. I'm sure you can come up with some of your own. Very obvious ones. Many network functions VNFs are going to be sensitive. Anything with sensitive data in it, customer personally identifiable information, healthcare, legal payroll, et cetera, et cetera, et cetera. And then you've got your IPsec, TLS endpoints, key management, auditing, logging processes, password processing, blockchain smart contracts. Anyone interested in blockchain DLT here? Okay. So if you're looking at smart contracts, whilst they're in process, they are very, very sensitive. Because if people can see them or change them, that's a bad thing. So, right, the problem statement. Who do you trust and how much? Let's assume we're going to go with a simple hybrid model just for simplicity to state what's going on here. Let's assume that you've got some workloads on the premise or on the cloud, and they're sitting on servers. In fact, they're sitting on servers even when you can't see them, right? You do know that the workloads do actually sit on somebody else. There's no cloud, it's just somebody else's computer, right? So there's always these servers. And some of the workloads aren't even yours, right? So you can't assume that Amazon or Rackspace or Google or Azure are going to give you your own dedicated hosts all the time. You're going to be sharing hosts, which should be all right all the time, of course. But what happens if, let's say, a malicious workload attacks yours? Yes, we know that this is supposed to be defendable against, and of course there are no bugs in any hypervisor code anywhere in the world. Yaha. So of course, you can get workload to workload, VM to VM, container to container attacks. That's a bad thing. Or, of course, one of your own workloads could be compromised. Also a bad thing. And here it gets really scary. What happens if a CSP admin is malicious? Because the way that containers and hypervisors and therefore VMs work is that if you have root access or hypervisor access, or you own the kernel on a host, you own the workloads. Say that again. If you have root access, hypervisor access, or own the kernel on a host, you own the workloads. You can see inside them, you can change them, you can do anything you want with them. So what that means is if a CSP admin is malicious, they can do whatever they want to your code. If you've got sensitive data in there, they can change it. If they've got a process that needs to run a particular way, they can stop it doing that. And of course, there's the issue of what if one of your admins is, well, let's not say malicious, but interested in your payroll data or your M&A data info. This is not just a problem with the cloud, okay? And I should also state, it's really important to understand this, that sometimes it's going to be better or easier or safer to host stuff on the cloud than internally. Because the people who run the cloud, they got a lot of people, they know what they're doing, they can keep up to date with patches, maybe not perfectly, but they may well have more resources to do that stuff and more expertise to do that stuff than you do, particularly if you're a small company who doesn't actually have a huge private cloud. So actually, there are times when you might think, you know, actually, it makes more sense to use the public cloud from a security point of view than it does from the, you know, to do it from internally. But at least you would hope you've got a decent chance of controlling and knowing your own admins. So this is the problem statement, okay? How do I know where to put stuff and what can I do to protect things wherever they are, okay? Now, generally, I'm going to take the view that you trust your on-premise cloud more than you do the public cloud. As I said, not always true, but let's take that as the starting point. Oh yeah, so we should say, you know, clouds are made up of VMs and containers, and they both suffer from this set of vulnerabilities, right? Just because you're using a container or using a VM doesn't mean this doesn't happen. Maybe, you know, slightly different attack vectors, but they've still got the same problem. Okay, so let's talk about 3 types of control that you might consider using when you're thinking about sensitive applications. This is what I call them. I call them contractual controls, architectural controls, and technical approaches, or approaches. And they should be complementary rather than exclusive. And you'll notice that I spent complementary correctly, okay? If it's like that, if they're working together, it's with an I if it's saying, yes, it's very nice, okay? Remember this, because Air Canada gets it wrong all the time, and it really winds me up. And they're not the only people. So please, if you learn one thing from this, it's how to spell complementary, right? Okay. It's 10's complement. Remember, as a kid, you learned 10's complement? 1 plus 9 makes 10, 2 plus... Complement like that with... Anyway, calm, breathe, right. Oh, dear, I went too fast on that. How do I go back? That's not what I wanted. Okay, I've missed a slide. So I'm going to... You'll have to look at the grey stuff. Sorry about this. So when we talk about contractual types of controls, we have a number of these. You've got privacy T's and C's, right? So when you go to Google or Azure or Rackspace or whoever it may be, your CSP, they will have T's and C's, right? They'll have SLAs. They'll have conditions of business. And what it basically comes down to is saying, if this stuff leaks, you, Amazon, will pay me $1 billion. Good luck with that, okay? But that's kind of what it comes down to. This is business. We know how to do business. And there may be ISO standards they adopt, or regulatory requirements is another one to look at. Telcos particularly, or healthcare providers have strong regulatory requirements. So maybe they do these things. But when it comes down to it, if you do a bad thing and we catch you, you pay out loads of money. Oh, and if our lawyers manage to make it stick, et cetera, et cetera, et cetera. So as I said in the big sort of red stamp thing, these are vital, but they're insufficient. You should make sure you do the due diligence on this so you understand what the liabilities of your CSP are and what your chances, frankly, of getting any money out of them if they fail in those responsibilities. So start doing this, but don't expect it's going to fix the problem. So architectural approaches, architectural controls. There are loads of these, but what it really comes down to is understanding what's going to be where and when. Okay? So you can break down your application and say, well, here are the sensitive parts. Maybe a microservice runs your sensitive parts, and that's the bit that I care about. You can do automation stuff. Say, well, we always make sure that something goes here. We automate the order in which this happens so that these bits are never exposed on the CSP. You should encrypt everywhere. We all encrypt everything, right? Please nod. Please. Yeah, okay, fine. No one's nodding. But we all encrypt everything all the time. Thank you. Next, you'll be telling me you turn SE Linux off. I don't even want to hear about that. If you do, I do not want to hear about it, okay? And neither does Dan Walsh. API controls. Making sure that you know who can access which components because you've got controls on the APIs. And not only that you have controls on them, but you audit and monitor those, please. Placement and scheduling are among the most important, I think. Saying, okay, well, we know this VM is sensitive, this container is sensitive, whatever it may be. It must never, ever go in the public cloud. It must always sit on these servers on-prem, as an example. You've got to monitor and audit. You can do policy, blah, blah, security controllers, principle of least privilege. These are the things that, as architects, we should be doing. We need to think about all of the tools in our arsenal and how to apply them to this sort of context so that we are protecting our data as much as possible. Knowing where it is, knowing where it might flow to, knowing who has access to it, knowing how long it lives somewhere, knowing it's backed up, all of those sorts of things. Do these all and do them now. Because this is nothing new here, right? We've been able to do all of this stuff since the dawn of time, by which I mean kind of when the internet was created, I guess, but So, we talked about network isolation. Oh no, we haven't yet. Well, I'm going to talk about network isolation and storage isolation. These are things we can do. We know how to create VLANs, VXLANs, all those sorts of things. And we know that when we want to move data from one place to another, we want to keep those flows separate, right? Keep the control flow separate, keep different layers, keep the presentation data separate from the database data, all of those sorts of things. And ditto for storage, right? Keep those things separate. Know where they are, encrypt them, whatever it may be. But the thing that I'm really interested in here is process isolation. Now, this is what hypervisors are supposed to do for you, right? They keep processes separate, but they don't deal with, remember the problem statement? They don't deal with that. They don't deal with the malicious actor at the host level, and they don't always deal with isolation even at the workload level. So what can you do? What technologies are there available to help you do this? HSMs. Who's ever played with, tried to program, used in anger an HSM? Okay, so there's a few of us there, right? Hands up and wave and shout if you loved it. It was loads of fun and cheap. Yeah, you just notice that no one is standing up and waving their hands, right? This is difficult stuff. They're expensive. They're difficult to program right. You're not going to be using HSMs for everything. There are times when they are absolutely the right thing. Don't get me wrong, but it's hard work. Okay, FPGAs. Who knows everyone know what an FPGA is? Okay, they're basically little programmable chips on the motherboard. They're becoming more available. They're very good for certain things like fast control of network traffic. You can program them up. Very, very cool stuff. They're not that expensive because they're turning up on motherboards. However, they are difficult to program, and if you want to pay someone to program one of these, the people who can anyone program FPGAs? Does anyone have this skill? Because if so, you're worth about $1 million a year before you get out of bed. So these are expensive things. And the last, TEEs, Trusted Execution Environments. So these are things like SGX from Intel, SEV from AMD. Okay, I'm going to do probably one last. Who's heard of either of these? Oh, fun. Nobody knows about these. Okay, they are very cool. Let's see if I've got a slide on them. No, I don't. Okay. Right. They're not widely available. We expect to see them in server hardware in the next 2 to 3 years being rolled out. What they allow you to do is stop that problem statement, okay? They allow you to, they're chip-based, so they're hardware-based, which is cool. And it allows you to run processes and keep data encrypted on the chip in such a way that the data never leaves the chip unencrypted. Even when it goes onto the bus and into RAM, it's always encrypted. And what that means is, even if you're the hypervisor owner, or you own the kernel, or you have rooted the OS, you still can't get in. It's kind of magic, right? So it's a whole bunch of new chipset instructions. So you need to program to that. That can be awkward. There's 2 different versions that are known about, being talked about today, which is the AMD SEV, which is at the VM level, but pretty easy to program. And SGX, which is the Intel level, which is at the process level, much more granular, but quite more difficult to program. But the point is, these allow you to address these issues and start thinking about saying, well, if my cloud provider, my CSP, provides TEs-enabled hardware, I can now start thinking about putting some of those sensitive applications out on the cloud, because they can prove to me, and I can prove to my auditors, that they cannot look at that stuff. How you provision them is complex, but doable. So I can now say, I can take my HIPAA stuff, I can take my credit card data, and even if I don't trust those contractual controls, I can make the architectural decision to deploy that stuff in other places, or even on my own premise, where I don't necessarily trust my own admins. We all trust our admins. I know we do. So the problem with this is that there's not everything's available yet. The Ts aren't ready to roll out. But what I want you to do to go away and start looking into this stuff, researching and understanding what difference it's going to make to your business and how you're going to change how you architect your applications. Because it will change how you think about all of these things. You've still got all those architectural controls, and you should certainly apply those architectural controls. But if you can now start moving things around in different ways, The sort of thing you might start thinking about doing was, okay, I'm really going to separate out this component, but I can now distribute that in different ways. Maybe bring it closer to the presentation layer, for instance, rather than having to traverse firewalls all over the place. So, summary. None of this stuff is perfect, right? The T's are going to be difficult to deploy. The architectural stuff is complex. It has limitations. The contractual stuff only takes you so far. In order to understand what to apply, you first need to understand what is sensitive. If you've got a big monolithic application and it's not componentized, or you can't say these are the bits that I need to care about and when, is it in transport, is it in storage, is it in process, then you're not going to be able to apply these controls. So you need to understand your applications and your data. After that, use what we have now and plan for new stuff. Start thinking about how you're going to change your practice. Think about how you're going to explain to the business and to your auditors as well, because that's going to be a nice uphill battle, right? That's always fun. So I've flown through that a bit. I'm going to say we've got some interesting stuff coming up tomorrow, and a big thank you. Oh, and before I'm going to go, I'm going to invite you to visit my blog, which is called Alice Eve Bob, aliceevebob.com. For those of you with a crypto background, you can have a little smile to yourself. And for those without a crypto background, well, we can all have a smile at your expense. So that's all fun. That's it. Thank you very much indeed. Go and have beers. The front. That's what easiest. Okay, cool.